Hello and welcome to this CU Boulder Flight Operations supplemental video. This supplemental video is an addition to the normal fixed wing maneuvers video, but this video uses an RC flight simulator to show control inputs along with UAS movement. This video doesn't completely show all the ACS standards, so please visit the original video for that detail. This video will cover the following maneuvers. Before we begin, we'll review what control inputs do what to this UAS. Here we have a twin otter, and as you can see moving and toggling, the switches in the upper left toggle the flaps for takeoff, landing, and normal positions. As you can see, moving the right stick up and down moves the elevator up and down. This controls pitch. Moving the right stick right and left moves the ailerons. This controls roll. Moving the left stick left and right controls the rudder, and that controls yaw. In flight, this is what each of these inputs look like. This is roll. This is pitch. And this is yaw. The first maneuver that we're now going to demonstrate is the normal takeoff and climb maneuver. As you can see here, the UAS is sitting on the center of the runway. We do a quick control check, and then a nice, smooth, full application of power is added using the left stick. From there, slight back pressure is increased on the elevator, and the aircraft climbs to a normal altitude. Pitch attitude is held constant, and then the aircraft levels off when it reaches its desired cruise altitude. Next maneuver we'll cover here is going to be the straight transect maneuver. And this maneuver will be entering from a downwind. So the aircraft is approaching from the right. When it gets near to in front of us, the pilot will use a little bit of right aileron and a little bit of up elevator to make the turn without losing altitude, and now fly out on a heading to some predetermined point. When said predetermined point is reached, left aileron will be added, and the aircraft will turn 180 degrees until it's facing the opposite direction in which it transected outward. Upon reaching that original starting point, the right aileron will be added again, and the aircraft will exit the maneuver in the same direction it entered. Next maneuver we're going to talk about is the box pattern maneuver. In this maneuver, we are going to start once again on the downwind and fly to a predetermined point. When reaching that point, right aileron is going to be added for a 90-degree input, and the aircraft's going to fly out on that new heading. Then another turn is going to be initiated for 90 degrees. Another turn is going to be added, turning 90 degrees. Each of these headings are well defined. And we have the last turn here, which exits in the same direction that we entered. The next maneuver we're going to talk about is turns around point. As you can see, the aircraft is entering on the downwind here. As the aircraft approaches the abeam point, left aileron is going to be added and back pressure is going to be added to keep the altitude of the UAS constant. Bank angle doesn't need to change too much throughout this maneuver because there's no wind, and we're going to exit in the same direction we started. The next maneuver we're going to talk about is slow flight. As you can see, we're entering slow flight from left to right here. Power is being reduced, flaps are being inputted. The aircraft altitude is being held by slowly increasing the back pressure on the right stick. When a slow airspeed is reached, the slow airspeed desired for slow flight, hold heading and altitude, and then slowly maneuver right and left to change heading and altitude. As you can see here, a box pattern is being made in slow flight. More and more back pressure is needed in these turns when the aircraft is flying slow. Recovery consists of adding full power, maintaining decent pitch attitude, and retracting the flaps. The next maneuver we're going to talk about is power off stalls. As you can see here, we're entering the power off stall from right to left. Power is being reduced, flaps are being added, back pressure on the right stick is required to hold altitude. More and more back pressure is required until the stall breaks, at which case The right stick is released, the nose is pointed down, full power is added, and the climb out is initiated. The next maneuver we're going to talk about is the power on stall. All right, starting this maneuver from a very slow airspeed, back pressure is increased simultaneously with power until the aircraft stalls, in which case the pitch is released, nose is pushed down, and because full power is already set, the aircraft just needs to climb out. Next maneuver we're going to talk about is the normal descent and landing. In this maneuver, you can see us approaching on the downwind. When we get a beam the numbers or beam the touchdown point, throttle is going to be reduced. Back pressure is going to be added. Flaps are going to be added. And the aircraft is slowly going to be turned on base and then onto final. Aircraft is then going to flare and land on the runway and maintain centerline direction control with the rudder. The last maneuver we're going to talk about today is low fuel, low battery, and engine failure with emergency landing. I'll be in the numbers. Power will be cut. Aircraft pitch will need to be pushed down to maintain best glide airspeed. And the aircraft will slowly present itself in the same pattern that it did for a normal landing. Thank you very much for watching. If you have any questions, please don't hesitate to reach out at the emails listed on the website.